Okay, next example. Second time trying to make the video of this since the first one I really flubbed up. So we have x squared minus x is greater than 20, which I've written here. X squared minus x is greater than 20. Very ugly looking 20, but that's what it is. Remember, in order to proceed with these, we're looking for positive and negative intervals. So that translates to, are we looking for greater than or less than 0? We need to see the 0 here. We're seeing 20. So we're going to move that 20 over to both sides. And so the statement we have now is x squared minus x minus 20 is greater than 0. So now we have the statement with the 0 and greater than 0. Any numbers bigger than 0, we're looking for positive numbers. So we're going to be looking for positive intervals here. First step, we take our inequality, x squared minus x minus 20, and we make it into an equation. And now we solve the equation by factoring. So we have x minus 5, x plus 4 equals 0. Again, I'm going to make a video that will have this factoring in it for you to watch. Each of these factors becomes a mini equation, equals 0, that we then solve. Add 5 to both sides, and we have x is equal to 5 over here. Subtract 4 from both sides, and we have x is equal to negative 4. So we have, in this case, two solutions, which will become our boundary points. Coming to our number line, we have a boundary point at negative 4, and we have another boundary point at 5. Again, I'm going to circle them. Just to be clear, these are my boundary points, not test values. So our number line, again, just like the first example, is divided into 3 intervals, negative infinity to negative 4, then from 4 to positive 5, and then to the right here, 5 to positive infinity. So we need to choose test values here. And I'm looking for my green marker and I can't find it, so we'll go with blue. So in this interval here, from negative infinity to negative 4, I'm going to go with the test value of negative 5. In between negative 4 and 5, I'm going to go with 0. To repeat, you could choose any numbers you want in these intervals. I said before, I like 0s and 1s because it tends to keep the math easier, but you can choose any number you want. I also tend to choose smaller numbers because in the interval from 5 to positive infinity, I mean, we could pick 1,029, but who wants to do the math with that number? So I am going to just go up 1 and make it 6. So there are the test values. So test value negative 5, test value of 0, and then test value of 6. So we have our test values. To see what's going on in that interval, if it's positive or negative, I'm going to take the test value, and again, you could make the substitution into the original inequality. I tend to use the factored form because it keeps the math a little bit simpler. So here we have negative 5. Negative 5 minus 5 is negative 10. We have a negative number. Negative 5 plus 4 is negative 1, another negative number. A negative times a negative is a positive. So in this interval with our test value of negative 5, we have positive activity going on. Now test value 0. Put it in here. 0 minus 5 is a negative number. 0 plus 4 is positive 4. Positive, a negative times a positive is a negative. So in this interval with the test value of 0, we have negative activity. Last but not least, we have our test value here of 6. So 6 minus 5 is 1, positive. 6 plus 4 is 10, positive. Positive times positive is positive. So we have identified the activity in each of our intervals if it's positive or negative. Now, which of these intervals is going to satisfy our solution? Go to our original inequality statement, positive. We're looking for positive activity. I found my green marker. So positive activity is here and here. So here and here is our positive activity. We see that we go on forever here in the positive direction and the negative direction. And now, in regards to our boundary points, because our original statement was just greater than, our boundary points are not included in the solution, and so we are going to have parentheses to show that. So there's our solution graphically. In interval notation, it's going to be here, negative infinity, coming from the left to negative 4, stop, and then we have a parentheses because it's not included, and then this union symbol to show that we have two intervals that work. So we're going to show it's both of them by using this union sign, and this now starts at 5 and goes to positive infinity. So this goes 5 to positive infinity. So there's our solution in interval notation and then graphically.